Welcome to the tutorial 3. In this tutorial we are going to see uh, thermal stress analysis of 2D component. Here we are going to take a square shape plate whose Young's modulus is 200 gigapascal and its Poisson ratio is 0.3. Coefficient of thermal expansion is 12 into 10 to the power 6 per degree Celsius. The total object is treated with a temperature of 50 degrees Celsius. We are going to analyze what happened when we are supposed to give 50 degrees Celsius to that. The object is analyzed by using ANSYS. Here the same thing, choose a preference, a structural preprocessor. On that material property, material models, before that material model we need to give element type add element. Add element, we need to choose solid. So from that solid 8 nodal 183, click OK. Options, in that option we need to give the thickness of the material, click OK and close. Then we need to give the real constant, especially we need to add the thickness of the material. So especially here the thickness is 100, the thickness is 100, and then give one close. Next one, material property. From that material model, click linear, elastic, isotropic, 2e power 5, and then Poisson ratio is 0.3. Click OK. Next one, thermal expansion. On that secant coefficient, we need to define the secant coefficient. Isotropic, here we are having a set of value called secant coefficient. It is 12 e power minus 6 is the thermal secant coefficient number. It will vary, depends upon the material. And then OK. Next one, close. Coming to here, next one is we need to create a model. Create. Here we are going to create an area by rectangle by 2 corner, width and height, because here we are using square section. Both the cross section is 500 cross 500. So with this also 500, and height is also 500. Okay, then we need to apply, we need to click meshing. Here size control, enable size control, area, all areas. Here I am going to give around 8. Click OK. Then mesh tool, click mesh, click here, then OK. The mesh is generated. Next one, we need to define the loads. For that we need to go for solution, define load, apply, structural displacement on lines, the left corner. OK. All degrees of freedom. OK. Next one, we are not going to do any physical load. Here our load is in temperature, so I will click temperature. It's an uniform temperature, so I'll click uniform and then I will give the value. Here the normally it is in Kelvin, so the value is 50 plus 273. Okay. Next one is go to solve, current ls. Okay, now it is solution is done, so our analysis is correct. Go to general post processor, plot result, contour plot, nodal solution, DOF with respect to Y component. Click OK. These are the displacements. Here the so much of displacement is taking place, so it's a red region where the highest stress or displacement taking place. Go to animation, model shape, click OK. Now the various animations are plotted. We can choose according to our requirement, and that's it about the tutorial number